We'll now move into taking a look at the regenerative Rankine cycle, which is another method that you can use to increase the thermal efficiency of the Rankine cycle itself. Now, we did see the regenerator earlier on when we looked at the Stirling engine. That was under gas power cycles. And if you recall, the regenerator in that case was a thermal mass whereby the energy of the heated fluid going through was transferred to the thermal mass, and then it was recovered by the cool fluid coming back through the regenerator. So regeneration essentially refers to taking energy from one part of the cycle and sending it to another. And so we will find a way by which we can do that for the steam power or Rankine cycle in this segment. So what the regenerator does with the regenerative Rankine is we take a little bit of steam that is coming out of the turbine as it's expanding, and we strip it off and we send it back to mix with the fluid coming out of the pump. And by doing that, what we do is we add thermal energy to the fluid out of the pump, thereby reducing the amount of energy that we have to add in the boiler. And the advantage that we get here, we can examine by recalling the Carnot efficiency. So that was the expression for the Carnot efficiency. And so the logic here So the logic here is that if you raise the temperature at which the heat is added, that is the TH, the thermal efficiency will go up. And so that's essentially what we're doing. We're raising the temperature at which we're adding heat to the cycle, and consequently we will result in increased thermal efficiency. Now, in doing this, I refer to a thing called a feed water heater. And with the regenerative Rankine, there are two different types of feed water heaters that we will be looking at. And sometimes we call these feed water heaters regenerators. So the first type that we have is what is referred to as being the open feed water heater. And the second one is the closed feed water heater. And sometimes you'll see this expressed in an acronym form as FWH for feed water heater and FWH. So you'll see open and closed FWH, and that's just shorthand expressing the feed water heater itself. So another advantage that we get out of these systems is that they minimize the amount of thermal shock to the boiler metal when we introduce a cold liquid coming out of the pump. So we heat up that liquid out of the pump, the feed water, and consequently we minimize any kind of thermal shock to the metal that may have been there before. So what we're going to do now in the next two segments, we're going to first of all look at the open feed water heater, and then we will take a look at the closed feed water heater.